Today we are going to graph. Okay? We're actually going to spend the next week on graphing. Okay? So we're going to have today we're going to graph sine and cosine. On Tuesday we're going to work backwards and we're going to look at graphs and write their equations. And then Wednesday we'll graph tangent, secant, and cosecant. Okay. And then we'll have a graphing quiz on Friday of next week. Okay. So, what does the graph of sine look like? So, we actually are going to reference our unit circle. Okay. If I want to construct the graph of sine, we're going to pay attention to all of our what coordinates?
Y.
All of our y coordinates. So at 0 radians, we begin here at 0. Right? And as our angles get bigger, these numbers get bigger until we reach 1. Right? And then, once we get to pi over 2, what happens to our y values? They get smaller until we get back to 0. And then what happens to all of our y values? We get negative. We go to -1. And then we rotate back to 0. Okay, so what does that look like? Okay. Me circling numbers and talking about what they are, okay, isn't a very good visual. But I do have this visual right here. Okay, so this is the unit circle. Okay, and there are an infinite number of coordinates on the unit circle. We only talk about the 16 special ones. Okay, so this is twisting around the unit circle and taking all of the y values and plotting them. Okay. So this is what the graph of sine looks like. At 0 radians, we're at 0. At pi over 2 radians, we're at 1. At pi, we're at 0. At 3 pi over 2, we hit -1. And at 2 pi, sine is 0. Okay. So all of, anytime I've asked you to evaluate sine of pi over 3, sine of 7 pi over 6, whatever. All of those values are there in that graph. Okay. So this is the parent function. Okay. I would like you to draw that red graph right there, the red piece. Okay. Now, I can keep rotating around the unit circle forward or backwards, and we're going to get the same pattern. Okay, so the sine graph oscillates in both directions forever. What do I mean by oscillates? Okay, oscillates means we're bouncing back and forth between values. Okay, so this is oscillating back and forth. Okay. So this pattern is going to repeat over and over and over and over. Now, obviously, we're not going to draw every single wave, okay? We'll focus on a chunk of the graph, but this is going to continue on in both directions. I'm just going to repeat that wave pattern. Okay, are you ready for cosine? Okay, now when we look at the unit circle, and I'll go back to that that cool GIF here in a second. GIF. Sorry, I said GIF. I meant GIF. GIF. Thank you, Lisa. Okay. I was thinking. Okay, so cosine at 0 is what? 1. Right? And then as we rotate up to pi over 2, our values get smaller until we hit 0. Right? And then as we rotate to pi, we go all the way to -1. Right? No. And we rotate. And at 3 pi over 2, the cosine is 0 until we rotate full circle to 2 pi and cosine is 1 again. Okay? Do you notice how those are similar values? Do you think the sine graph is going to look similar to the cosine graph?
It's going to some that aren't the like high half. Isn't it going to be like alternate? It's going to be reversed.
It's just going to it's going to have the same pattern, but the pattern starts in a different place. Okay, so this time, okay, the cosine of 0 is 1. Cosine of pi over 2 is 0. The cosine of pi is -1. The cosine of 3 pi over 2 is 0. And then back to the cosine of 2 pi is 1. Okay, and just like the sine function, okay, it's going to repeat over and over and over and over. All right, so you see all of these waves. They go on forever in both directions. We're only going to focus on a chunk of the graph at a time. Okay, and I'll tell you what that chunk is going to be called. But here is the parent graph. Okay, so this is what cosine looks like. Okay, so the red part of the graph is what I want you to copy down. Okay, so now I want to give you a couple vocab words. Okay, so we can describe some things that are happening in this picture. Okay, so we need a way to describe this chunk of the graph. Okay, because this chunk repeats over and over and over, just like the red chunk of the sine graph that repeats over and over and over and over. Okay, so the first word we're going to talk about is amplitude. Okay, amplitude. What do you think of when you hear that word? Okay, frequency. Do you know anything about frequency waves? Okay. You say something? Okay, amplitude. Okay, so Sean said frequency. Okay, and if you know anything about science, frequency has waves, right? Okay, well that's what amplitude is referring to. We're referring to the height of these waves. So the sine and cosine, they're waves, right? So the amplitude is half of the vertical distance between the highest and lowest part of our wave. of the vertical distance between the highest and lowest points. So you graphed sine and cosine on your paper, right? Y equals the cosine of x, y equals the sine of x. What's the amplitude of those graphs? You graphed them on your paper, so look at your paper. What's the amplitude of those graphs? 1. Okay. I'll go back to the cosine graph, okay? So this stretches from -1 to 1, right? Which is a total of 2 units, so our amplitude is 1, okay? Sometimes I even like to think of it as how far away are we from the middle of our graph, okay? From here to here is 1, from here to here is 1. Our total height is 2, so our amplitude is 1, okay? Okay, so that's describing our height of our graph, if you will. We need something to describe the length of our graph. Because you notice that this chunk is just going to repeat over and over and over again. Okay? So the period is referring to the horizontal distance between a point and then the next point where we're going to start to repeat. So the red that I had you graph, we consider 1 period because at those points, it's going to start repeating again. Okay, so the period is kind of that unique part of the graph before we begin to repeat again. So we've graphed our 2 parent functions, right? How long horizontally does it take before those graphs are going to start to repeat again?
Too high.
Very good. Okay. If you notice, the graphs that you put down on your paper, they stretch from 0 to 2 pi, and then they were going to start to repeat again. Okay? So that means our period is 2 pi. Okay? I'll go back to the picture. From 0 to 2 pi, it takes us to draw that wave. And then here at 2 pi, we're going to start repeating again. So our period is 2 pi. All right. So what we're going to need to be able to do is identify from our equation what is the amplitude, what is the period, and where do we start drawing our graph. Okay? There could be shifts up horizontally or vertically. Okay, so we need to identify what's the amplitude, what's the period, where do we start drawing our graph before we can even begin to graph these. Okay, so we need to know a few things. Okay, so I want you to go ahead and write these down. Okay, and these are going to be the forms of our equations that we'll refer to for the next week. Okay, A, B, C, and D. So the first thing I want you to think about, okay, because remember, when we have transformations, they're the same with everything, okay? How they affect our graph is the same. So I want you to think about, what did that number in front of our function, that a, what did it do to our other functions back like in chapter 1? Remember?
Shrink or stretch?
Okay, it shrunk or it stretched it, okay? So if we're talking about shrinking or stretching, what could that affect?
Vertical frequency?
Okay, the amplitude, very good. Whatever A is, that's our amplitude. Now I have absolute value because amplitude has to be positive, and it's possible that A could be negative. What would that mean if A is negative?
So if we try
Not quite, but you're on the right train of thought. What does that negative mean? It reflects, right? If we had an x squared and we put a negative, it would flip upside down, right? So if there's a negative, that just means we're going to reflect our graph. And we will draw pictures of what that looks like for both sine and cosine here in a little bit. Okay. Okay. So a number multiplied to the outside of our function was a stretch or shrink vertically. What about this b multiplied on the inside?
horizontal.
Okay, it's going to be a stretch or a shrink horizontally. Well, what would our sine or cosine graph be affected horizontally? What's our other what word associates with horizontal distance? Our period, okay? So the period we find by taking 2 pi over b. 2 pi is the period of our parent functions, okay? B is going to affect that, all right? So we're going to take 2 pi divided by b to figure out what our period is. Okay. And then C and D. C is a what is he doing? Okay, left or right shift. D is up and down. Now, there's this B right here, which is affecting C. Okay, so it's not just over C and up D. Okay, that B is affecting C. So we're going to describe our movement as C over B, comma D. And this is what I'm going to refer to as our starting point. This is going to tell us where to start drawing our graph. Okay, so what we're going to do, we're going to have 2 examples. We are just going to identify these things about our graph, and then I'm going to give you a little handout, and we're going to talk about how to graph these. Okay, so are we ready? All right. So we'll start here. just write down y equals 4 sine of 2x minus pi over 3 minus 2. Okay, so first of all, our amplitude. Sean, what is it?
4.
Our amplitude is 4 because A is 4. Okay, it's positive, so there's not a reflection. Our period, how do we find it, Layton?
2 pi over b.
Okay, 2 pi over b. And what is b? 2. So our period is pi. And then our starting point is c over b comma d. What is our c value? Thank you, pi over 3. Since it's minus pi over 3, c is positive. Okay, divided by our b value is 2. And then our d value is this negative 2. What is pi over 3 divided by 2? Pi over 6. So our starting point is pi over 6, negative 2. Makes sense. We'll try another one. Go ahead and write this one down. Maybe. There we go. What's our amplitude? Thank you for saying just 4. It is a positive 4, but A is negative, so we need to make a note to ourselves that this is going to be a reflected graph. Okay, and here in about 3 minutes, I'll show you what that looks like. Okay. Our period, we find by taking 2 pi divided by b. What is b in this example? What? It is just 1x. So our period is 2 pi. Okay? And then our starting point. What is our c value? Be careful. It is negative 3 pi over 2. Divided by our b value, which is 1. And since we aren't adding any number over here, our d value is 0. So our starting point is negative 3 pi over 2, 0. Okay. So, let's put some things together here. I'm going to give you a little handout. We are going to graph using the framing method. Okay. Okay, so what's the framing method? This is our frame. Okay, we are going to draw a starting point, and then we are going to draw a rectangle where we go up and down our amplitude and over our period. Okay, so we're going to plot our starting point. We're going to draw our frame by going up our amplitude, down our amplitude, and then over the length of our period. Okay, then do you see how I have those dotted lines? Okay, we're going to split our frame in half lengthwise and then into fourths widthwise, I guess, if you want to say that. Okay. And then we're going to know where to put our points. Okay, there's going to be 5 important points for each period of the graph. Okay, so if we can split our frame like this, those intersection points are going to tell us where to plot our points. So what I want everybody to do is I want you on each of your 4 frames to plot where the starting point is. So in the middle of the left side. Right? And then I want you to split your graph with dotted lines like I have up here. So you have 4 frames where I need you to draw these dotted lines. Okay? So, once you have your frame drawn, the graph is very easy. Okay? So for a sine curve, we know it looks like an S. Do you agree? So for a sine curve, we're going to plot a point at the starting point, and then we're going to go up here to the top at the dotted line. We're going to come back to the middle at the dotted line. Then we're going to go to the bottom at the dotted line, and then back to where we started for our S. Okay. How is the sign with a negative A going to look different? It's going to go down first. Now, here is what is important. Everybody, stop writing and listen to my words. The cosine does not begin at the starting point. The starting point tells us where our frame starts, but not our graph. The cosine actually has to start in the corner and then hit these points right here. Okay. And if the cosine has a negative A, which corner will it begin in? The bottom corner. And then hit each of these dotted lines. So on that handout, it kind of goes through the instructions, okay? We need to identify everything first. Then we can draw our frame, like we have here. It's going to be one of these frames. And from there, we'll label what points we have. Okay. So we're going to try to get through 2 examples. Are you ready? Example number 1. What is our amplitude? 1. Okay, now we have a negative A, so I'm going to put a note to myself that we're going to have a reflection, okay? Our period, 2 pi over B. What is B? Our B is 1. So our period is 2 pi. Then, our starting point. What is our C value? Negative pi over 2 divided by B, which is 1, and our G value is, so this is negative pi over 2. All right, so our starting point is negative pi over 2, 3. I'm not going to draw our x and y axis until the very end, okay? So here's our starting point. We're going to go up 1 and down 1. And we're going to go over how far? 2 pi. Okay, so I'm going to make little marks right here. If this is negative pi over 2, and I went over 2 pi, where did we stop? We started at negative pi over 2, we went over 2 pi. What is negative pi over 2 plus 2 pi? Thank you. Then we're going to split it in half. What is in the middle of negative pi over 2 and 3 pi over 2? It's a midpoint, so we can add those two numbers together and divide by 2. What is negative half plus 3 halves divided by 2? 1 half. So we're at pi over 2. What's in the middle of negative pi over 2 and pi over 2? And what is in the middle of pi over 2 and 3 pi over 2? Pi. So this is actually our y-axis right here. And this is our x-axis. Okay, so that's where we are. Okay, now we have everything drawn. We can fill in our graph. This is a sine graph with a negative a. So we begin at our starting point, and then we go down. what I would like you to do is label these 5 important points. Okay? So this one's already labeled negative pi over 2, 3. This one is at 0, 2. Here we're at pi over 2, 3. This one is at pi. And here we're back to 3 pi over 2. You're going to have to work with fractions. It's going to happen. Okay? So what I did is I labeled all of these dotted lines so I knew where I was, and then I could label the points at the end. Okay? I didn't worry about drawing my x and y axis until the end because I don't want you to be so focused on where you are that you mess up how long these are. Okay? Now, I didn't have time to get another example in. This is your homework. What I'm going to do is at the end of the day, I'll record another example so that if you want to watch another example, you can. Okay? I didn't want to rush through anything. So I will do 1, if not 2 more examples in another video. Okay? Now, you have to do your homework. If you do not practice these graphs, you're going to be completely lost on Tuesday. Okay? Yes?
For the last example, it was 5, and I thought it was 3.
Yeah, it should be 3. Thank you.
Mrs. Sommer?
Yes.
I'm going to be absent on Tuesday.